Hello folks, welcome to the Age of Asparagus and part 8 of making a 3D top-down shooter in Godot. This will be the last video in this first phase of the series. The next phase will focus on random level generation. By the end of this video, the player won't be able to shoot through walls anymore, we'll improve aiming in a couple ways, tidy up a bit of code, and finally we'll reorganize all our scenes and scripts and other resources. So one bug we've had for a while now is that we can shoot through our barriers if we get it at the right angle. So here's our problem. Imagine this is a player with their gun firing a bullet at a barrier. Here's the bullet. We'll say this is on frame 1, and then on frame 2, maybe it's here. On frame 3, maybe it's here. And on frame 4, of course, these should be a little more evenly spaced out. Hopefully, if this is our physics process, the bullet is here. So the problem is our collision detection occurs when it crosses the barrier of the collision shape. And if we happen to be shooting at the right angle, at the right speed, with projectiles that are too small, it won't actually cross the barrier. So one way we could solve that problem is we could double the frame rate of the physics process. So by default in Godot it's 60 frames per second. The physics is calculated. So we could calculate physics 120 times a second, in which case there would be a frame in between where a calculation would occur and detect that collision. How we would do that is if we went to the project settings and in the general tab scroll down to, I went too far, we're going to go to, where are we going? Physics. Physics, common. We could change physics FPS to, let's just say, 120, or you could even go up to 180. And if I run this now, you'll see that it does pretty good job and it stops it. Pretty good. Now if I'm clipping right through, of course that's still going to be a problem. It's not really though. So this is one way to solve it. I found actually I could still clip through if I just got the right angle even at 120. So we're not going to do that. I'm going to turn that back to 60. Also, it seems a little aggressive and unnecessary. Another way we could solve the problem is if we just change the size of our collision shape for the bullet. Now visually we want the bullet to look like this, but it's moving fast. So we can just expand the shape of the bullet. Imagine something like this, where this is the collision shape of our bullet. And if our bullets had these, then no matter where they are, they would collide with the edge of our obstacles. Now, if these bullets were going even faster, we might run into this problem again, and we'd have to adjust the length of this collision shape based on the speed of the weapons. But for our purposes, just expanding this to about 3 times the size of the bullet or so should easily solve our problem. So let's go to our bullet scene. Bullet up top. And we're going to click our collision shape, and I'm going to go to hit 1 here. I gotta have my mouse hovering over this area. And remember, what way does our bullet move? Our bullet's gonna move in the Z direction, I believe. So we should probably hit 3. And then I'm gonna expand the collision shape. Just something like that. So it's a little bit longer. So the bullet could collide. We'll detect collisions here, but visually it'll just be like that. So let's see if that worked. And that worked beautifully. In fact, it's even not letting us clip anymore because you can see the bullet starting to go, but then as soon as it appears, it detects the collision. Funny. Anyway, that solves the major problem of us being able to shoot through barriers. Okay, another problem we have is that when we fire, our bullets aren't exactly shooting at the mouse. They're kind of offset a little bit. Okay, so our problem is if our mouse cursor is pointing on our level here, and our player is looking at that position, shifted up, of course, by the height of the player, then the bullets are actually shooting off to the side a little bit because the bullets are not coming from the center of the player. They're coming from the muzzle of the weapon. So what we need to do is we somehow need to get that bullet to be at this point. So what we're going to do is we already have the player looking at our target raised up. So we're just going to have our hand also turn to look at that point. So by turning our hand, it'll also turn the weapon as well as the muzzle and any parts connected to it. So what we should end up with is the hand turning slightly based on where the mouse is. And then the closer the mouse gets to the player, the more the hand will turn. And this might have a neat effect because now we have a little bit of dynamics. It's just not a static player holding a static weapon. The weapon will actually kind of turn a little bit to shoot at the target. Let's try it. So let's go to the level script, our main script here, because that's where we actually do all of the looking at. And let's add a reference to the player's hand. We'll add a new onReady var. We'll just call it hand, and we'll set it equal to the player's hand. And I think we can just cycle down here. And assuming we don't move the hand relative to its position on the body and the body on the player, that should work for us for now. If we ever do move it, I'm sure it'll throw us a bunch of errors. And down here, let's also have the hand look at that position. And we'll use the same vector3 dot up. Okay, let's see what happens here. Okay. Well, the gun is moving now. That's good, but obviously it's pointing in the wrong direction. So what I should be able to do is double click here and hit Alt F1, but that does stuff my OS and I don't want to bother turning it off. So I'm going to change that for myself so I can do the quick lookup here. And so I'm going to go to Editor, Editor Settings, and then click over to the Shortcuts tab and type help here. And it's going to be one of these, the contextual help in the script text editor. And I'm going to get rid of that one and click the little pencil, and I'm going to use Control F1, which isn't being used for me for anything. So now I'm going to Control F1, and you're going to Alt F1 if you've left it the default. And now I can jump to look at the docs for this. So remember in 3D look at, and you remember the look at rotates itself so that the local Z axis points towards the target. So let's go to our player script, our player scene, and take a look at the hand. There's the hand, and of course the hand, that's the positive Z direction. So we're going to rotate this, make sure snap is on there, and then you can rotate it to point backwards. So now the hand will look at the negative Z direction, we'll look at it. And this will probably mess up our gun is pointing backwards still. So let's go to our gun, because our gun is getting mounted in that direction. Gun scene, and let's have our gun, and we'll just do the same thing. We'll just rotate that. Oops. Control Z, I make sure snap is on, and gonna rotate it 180 degrees. And then you hit 3 on the number pad, and let's move it up like that. Did that work? There we go. Hey, look at that. And now, what happens? Look at how the gun changes slightly to point always where... That's neat, eh? Okay. So now it should actually fire where I'm pointing. Now here it looks offset, but it's not because it's shooting in the air above my pointer. It's trying really hard to point. That's actually kind of annoying and weird. So we only want it to point when it's not too close. So let's go back to the level script here, and let's just do a little check to see how far away the pointer is. So we have the look at me vector, and we know the hand's position. So let's subtract them and check how long that is. Let's just create a new var here. Distance to pointer. Distance to pointer equals, and we're going to want to go hand global transform dot origin, and then we'll subtract the look at me vector. Then we want to check if the distance to pointer dot length. So we're going to get the length of that vector, and we'll say less than 2. You can experiment with this. Actually, I think maybe 3. We'll only point the gun if the pointer is a distance away. So you can see it's moving to try and point, and that didn't work. Whoopsie. Obviously we want the distance to be greater than 3. right? Yeah, greater than 3 will look at it. You can see it's looking, it's trying, it's turning, but then it's not going to do it if we're too close. So it doesn't do that weird shoot across his belly. Another issue we have with our aiming here is that the ray that's coming out of the camera and shooting through the scene is also detecting collisions with any object in the scene, like this one, for example. You can see if I'm aiming at the top of his head and then I slightly move off to the ground, you can see the player jumps, and the same thing happens here. There's a little jump, right? So we only want that ray to interact with the ground. So let's go take a look at the method we're using. That's in our levels main script here. In the physics process, we're using right here, intersect ray. So that's the ray that's shooting out of the camera, and it's going to some far off target that we've calculated, that laser beam that goes right through the mouse cursor and interacts with our 3D scene. So let's get the contextual help here with Alt F1, or for me Control F1, and I'm going to make sure I'm looking at the 3D one here. And you notice one of the parameters we can provide is a collision mask, and we can give it an integer, and that will allow us to tell it which layers we want it to collide with. Right now, our ground and all our obstacles are on the same world layer, so let's create another layer just for our ground. We'll leave it on the world layer as well, but in our project settings, we'll scroll down near the bottom here to layer names, 3D physics, and world layer. We're going to add another one, and that's going to be the ground. That's all we need. Let's close that, and we'll go to the ground. Over on the right in the inspector, here under collision layers, we're going to add the ground layer, which should be number 4. And I actually thought we had to restart the editor, but it looks like it's picking up the new name. That's pretty awesome. So we want it on the ground layer. And now what we need to do for that ray, that intersect ray, is we need to do the equivalent of ticking this box here, and only this box, so that it will only interact with the ground. But we need to provide it with an integer. And that integer we provide is the value of the layer right there. See where it says value 8? So we're only interacting with one layer, which is pretty easy. We can just give it the number 8. But if you want to do something more complicated, like say you wanted to also interact with enemies and the ground, then what you need to do is you need to add up the values. So value 4, value 8, you'd provide that collision mask with a value of 12, and that would be the equivalent of masking those two layers. Okay, so value 8, let's go see if this works. Here we have ray origin, ray target, and first the next parameter is an array of things to exclude. We don't want to actually exclude anything, and GDScript doesn't have name parameters, so we can't really skip it. We're just going to provide it with the default value of an empty array, an empty list, and then the next one we want is the collision mask here, and we'll give it a value of 8. And that should do it. I'm saving it here, I'm running it, and you should just, it won't jump around anymore. It's a little more obvious on the other side. Yep, it's working. Okay, another tiny problem. Our player, in our player script, we have a move and slide, but we're doing it inside the process function, and if we check the contextual help here for move and slide, it does say right here, look, this method should be used in node.physics process. So we should be doing this in physics process. I don't know if it matters for us. I don't think it'll affect our game much, but physics process does do a lot of magical stuff behind the scenes to make sure that all those collisions are properly coordinated. So let's just play it safe. It's always good to follow the suggestions of the docs unless you know a reason why not to. So let's switch that function to physics process in the player script. And finally, the last little cleanup thing here is I accidentally named a script node.gd, and that's not helpful. We'll have no idea what that is just by looking at its name. So it looks like that was supposed to be wave.gd, so I'm going to rename it here. If you're renaming files, make sure you do them in the Godot editor and not in your operating system's file explorer. If you rename or move files in the editor, then it should update references within the scenes to those scripts and those resources and other files. So for example here, let's finish up by organizing our project a bit. We did last time create this enemy folder, and that's because there's one exception here in our enemy script. If you move files that have the full path like this in them, that won't update. But the references, for example, to enemy.gd within the enemy scene, right there, that will update. In fact, TSCN stands for text scene. This is actually just a text file, and here's my file explorer, and if I open enemy.tscn with a text editor, I can see here it's referenced to the enemy.gd script. And if I move that enemy.gd script into our enemy folder, I can go back to that text file and it's been updated. I'm going to reload it here, and you can see that the enemy scene has updated its reference. Now it goes into the enemy folder and finds the enemy script. So that's pretty nice, because now we can organize our project. I'm going to put the enemy scene in the enemy folder. I'm going to create another new folder for weapons and anything weapon related. So the bullet script, I'm going to hold control and add the bullet scene, the guns and the gun controller stuff into the weapons. I also typoed weapons. It should be EA. Okay. You notice there are some errors happening here because I have scenes open that are referring to it. So we can close these, and I'm also going to, you notice as we change the name of scripts or move scripts around, they disappear from here, so we can just close all scripts as well while we're doing this. Let's add a new folder for the player, and we'll move the player and player script and player scene in there. What else do we got here? We should probably add a new folder for spawning, so we can move the spawner and the wave scripts into spawning, and we'll finally add a level, and here we'll add the level scene, the level grid, the ground grid, the actual texture itself. Move those into level. Stats is used by both the enemy and the player. I'm just going to leave it out here for now. Obstacle material we can move into the level, and that's a lot nicer looking, isn't it? So here's the big question. If we open up our level scene, does it break? Looks good. Should always check if we broke our game or not, right? Alright, looks like we're in business. One more silly mistake I've made, thanks to John II for pointing this out in the last video. If we go to the player scene and we click on the stats here, changing the max hit points in the editor here doesn't actually get picked up when we run our game. And one of the reasons is because in the stats script, the way this code is going to run is it's going to take the max hit points as its default value at 10, and then it's going to set the current hit points to the max hit points, which is 10. And then at some point between there and when the ready method runs, it's going to take the stats value here from the editor. But after that happens, we never actually update the current hit points again, so the current hit points will always be 10. So what we actually need to do is take this line and put it in the ready method so that it'll pick up the new max hit points. However, if you remember, that's the same thing as just saying onReadyVar. So if you remember, the onReady syntactic sugar we have here just delays the assignment of that variable until the ready method. So now when we play our level, we should have the proper amount of hit points, which is 7. That concludes the first phase of the series to create the game's foundation. In phase 2, we'll create a tool for generating levels of various sizes and random obstacle placement that are reproducible with seeds. In phase 3, we'll mostly be adding game juice such as particle effects for death and weapon effects, as well as weapon variation, recoil, and reloading. Finally, in phase 4, if we make it that far, will be our finishing touches like sound effects, music, menus, and maybe a simple heads-up display. If you're enjoying the series so far or have any requests, we'd love to see your comments. See you next week.